Hello friends, so in today's question, find the least horizontal force P to start motion of any part of the system of the three blocks resting upon one another as shown in the figure. The weights of the block are A 300 Newton, B 100 Newton and C 200 Newton. Between A and B, the coefficient of friction is 0.3. Between B and C, it is 0.2, and between C and ground it is given as 0.1. So this is the figure. The force is being applied on block A, and they are one above another with respective friction coefficient given as 0.3, 0.2 and 0.1. So we are going to find the least amount of force to start motion in any part of the system. Okay. So we are going to divide the system based on, as there are three blocks. So first of all, we are going to assume that only A block moves, find the value of P. Then we are going to assume that A and B both move together and find the value of P. And then finally we assume that all the three blocks move together with the force P and respectively find the value of P. So we assume let only block A moves. Okay. So if block A moves only, we can see from here that force P, so this is our block A, force P is being applied on it, and let us suppose there is a frictional force Fr1 on it, and the value of Fr1 we can calculate. Fr1 will be equal to mu into normal n, and n is nothing but the weight of A, that is 300 Newton. So mu1 is given as 0.3. So we can F1 is equal to 0.3 into 300, which will be coming equal to as 90 Newton. So you can say let only block A moves, then the summation of the forces in x direction, okay, let us say this is x and this is y, the summation of forces in x direction will be equal to 0. So you can say summation of forces in fx is equal to 0. So from here we can say P minus of Fr will be 0. We know Fr1 is 90. So from here we can say P is equal to 90 Newton. So this is our case 1 when block A is moving alone. Next case, we say let blocks A and B move together. Let the blocks A and B move together. So this is A and this is block B. Force is being applied. So this is a combined. So let us draw combined block. This is force P, and we are going to have a friction, let us suppose Fr2, and we can find out value of Fr2. Let us call this N1, much more easier. So Fr2 will be equal to mu2 into N2, and value of mu2 is 0.2 multiplied by A is 300 and B is 100. So this will be 400. So we get our Fr2 is equal to 80. this is our FR2. So once again, the summation in, you can say, horizontal will be equal to 0. Then summation of all the forces in X will be 0, and we can say P minus FR2 will be 0. FR2 is 80 Newton, so we can say P is equal to 80 Newton. So this is our case 2, and we have our case 3. We assume that all the 3 blocks move together. Okay. You can say blocks A, B and C move together. So we say this is our A block, this is our B, and this is our C block, and they are moving together. A force is P, and there is a friction between this. Let us call this FR3. So we can say that our FR3 will be equal to mu3 into N3, and the value of is given as 0.1, and the weight is given as 300 plus 100 plus 200, so this will be coming as 600. So from here we can write that our FR3 is nothing but equal to 60 Newton. So once again you can say summation in X direction will be equal to 0. So we can say P minus FR3 will be 0. FR3 is 60 Newton, so P will be equal to 60 Newton. So we were asked find the least value of horizontal force in which any part of the system moves. Okay, so we find out 3 values of P. One is 60, another was 80, and the first one was 90. So when P is 90, only A is going to move. When P is 80, A and B are going to move, and when P is 60, the entire system is going to move. Okay, so it is asked that any part of the system is going to move, so we are supposed to find out that value of P. So from here we can say when P is equal to 16 Newton, system of A plus B plus C is going to move together which means this is the minimum value of P for which the system moves. So it means the answer will be equal to P is equal to 60 Newton. So this question was quite simple. Thank you.